Okay, so now we're going to look at number 40. Number 40 says, suppose the student council has asked you to form a committee to run a bake sale. The committee needs from 7 to 10 members, and the number of seniors should be greater than the number of juniors. Then it says, write a system of inequalities to model the problem. So in this case, if you can tell, with student council, they're talking about seniors and juniors. So it looks like seniors and juniors are the only ones really involved in this committee for the bake sale. So therefore, I'm going to identify my variables. Remember, you get a point for that. And so I'm just going to say S equals seniors and J equals juniors. Okay? With the word problem, you take it one sentence at a time. Okay? So it says, suppose the student council has asked you to form a committee to run a bake sale. Okay, well, that sentence is pretty useless. It just tells you you're going to run a bake sale. Nothing you can derive from that. Okay? But the next sentence, the committee needs from 7 to 10 members. So from 7 to 10 members, that means at least 7 and at most 10. So you can write this one of two ways. You can write it as, S plus J is greater than or equal to 7. S plus J is, not greater than or equal to, less than or equal to 10. So that could be one way, or you could write it as 7 is less than or equal to S plus J, which is less than or equal to 10. So either way that you want to write it, you don't write both. You write one or the other. Okay, but that would be a half a point to a whole point for that. Now let's look at the next sentence. The next sentence says the number of seniors should be greater than the number of juniors. So that means seniors has to be greater than juniors. That one was actually a lot easier than that banana bread one. Don't you agree? And it's not greater than or equal to because it says it should be greater than. Okay, so it downright tells you what sign to use for the inequality. So that is your second piece there. Okay, and finally, the thing you can never forget is that both variables have to be greater than or equal to 0. You cannot have a negative, senior class or negative juniors or things like that. Okay, so those would be the three kind of components of the system of inequalities to model the problem. So that is what you would do for any word problems. You saw two different ones. A lot of them are very similar to the two that I explained to you. That's why I wanted to cover those, and especially the banana and nut bread one. Please let me know if you need further clarification on that, because sometimes it trips people up, which is understandable. It's not uncommon that that would happen. Now, the next piece that I want to look at, and the directions for it will be, write a system of inequalities to describe each shaded figure. Okay, so what we're actually going to see here is a nice little graph. Okay, so let's look at this first one. And actually, I took this one from the book. This is like number 50 in the book. Actually, it is not like it. It is number 50 in the book. Okay, and I'm going to go ahead and pause it so that way I can draw it. You can just let this video keep playing. Okay, so I kind of fixed it so that way we could almost zoom in. So I did a larger graph so that way it's a little bit better to see. So this is number 50 from your book. And so obviously it's a trapezoid. Hopefully you remember that from geometry. And it shows the different points that you have. What I recommend when you write the system of inequalities to describe the shaded figure, I recommend labeling the sides. Now, personally, I do this for you, like you'll see on your homework assignment that it's labeled, or on a quiz or test, it'll be labeled. But I recommend if you're on your own to go ahead and label it. So let's look at line number 1. So that's this one here. Okay, so it's a horizontal line. That means that x can be anything, but y has to be a number. So y has to be 3, which you can kind of tell from the ordered pairs. Now I have to decide the sign. Now it is solid, so it's going to be equal to, and because it's shaded below, it's going to be less than or equal to. And now I just handled the first line. So now let's look at line number 2. Obviously, we'll do a y. Now, if you notice, I could figure out the slope. I'm going down 1, 2, 3. You can't really see my marks. I'm making down 1, 2, 3, and right 1. So that means that I'm going to have a negative 3x because I went down 3 and right 1. Okay. But now I need to figure out this whole, y-intercept thing. Okay. So there are a number of different things. Whenever you do a graph, like you can, do kind of like a point slope kind of form or something like that. Because you have the slope and you have a point, you can probably figure out the y-intercept from that. Personally, what I do is I just extend the line. To me, it's a little bit easier, but you kind of have to do whatever works best for you. So because I go down 3 and right 1, I'm going to go up 3, 1, 2, 3, and left 1. And then I'm going to have to go up 1, 2, I'm kind of going off the graph, 2, 3, and then left 1 again. So I'm kind of off the graph over here. But I end up, if you count, this is at 3, 4, 5, 6, and then I have 7, 8, 9. So therefore, that is negative 3x plus 9. And then finally I have to figure out where it's shaded. So because it's shaded on this side, it's shaded below. So that's going to be less than or equal to. So now I handled line number 2. Now I'm going to look at the third one. So the third one that we have here, again, it's a horizontal line. So therefore it's going to be y equals a number, and that number is just the y value of those 2 points, which is 0. And because it's shaded above, it's going to be greater than or equal to. Finally, let's look at number 4. So for number 4, obviously it's going to be y equals something. I'm going to utilize the slope. So I go up 1, I'm going to go up 1, 2, 3, and right 1. So that means I'm going to have 3x. And then I need to figure out my y-intercept. Again, I personally just extend the line and, use the slope to extend the line. So I'm going to go up 1, 2, 3, right 1, and then 1, 2, and I'm off the graph again, 3, and right 1. So that brings me at 9 again. So that's going to be 3x plus 9. And then because it is shaded going to the right, that is technically below the line, so it is going to be less than or equal to for that one. So hopefully, you can kind of utilize this to be able to help you out. I do have one more example for you, but it's one that I created from scratch. Okay. So here's the figure that I created. Okay. And so it's a little bit different because while you do see a triangle, it looks a little bit different than like the quadrilateral that we just saw. Again, I highly recommend that you label. So I'll label this, this line here as 1. I'll label this line here as 2 and this line here as 3. Okay, so I want to look at my first graph. So I'm looking at this dashed line right there. It's a little bit gross now that I noticed all of that, all of those lines that I wrote. So this is 1, this is 2, this is 3. That might be a little bit more helpful. So I'm going to first look at this dashed line. So my slope is going from this point to this point. I'm going to go up 1 and right 2. So that means it's a positive 1/2 x. And then I'm going to look at that y-intercept, and that y-intercept is at 3. Okay. Now it is shaded below, so therefore it's going to be less than, and it's just going to stay as less than because it is dashed. So that's what makes it a little bit different than the one that we just saw in that last problem. Now number 2 here, it is solid, so I know I'm going to have an equal to part. I'm going to look at the 2 points and figure out the slope. It's down 1, right 1. So that means that it's going to be a negative x. And then the y-intercept is actually at 0. So there's truly no need to write a plus 0. That's kind of understood. You can. It's not like it's necessarily wrong, but a lot of people just don't write that because it's understood. And the shading is above the line, so therefore it is going to be a greater than or equal to for that line. And then finally we have our third one. Our third one is a vertical line. Anytime you have a vertical line, x has to be a number. Y can be anything, okay, but x has to be a certain number. So x is actually at 2, okay, because it's 2 to the right. So notice, here y is at 1, 2, 3, 4, 5, 6. Y is at 6, but x is at 2. Here x is at 2, but y is at -1. So if you ever are unsure, maybe pick 2 points and write what those ordered pairs are. And then you'll be able to notice that x is the same number, therefore you have to have an x and not a y. Okay, now because it's shaded on the left, it is going to be less than, and it's just going to stay at less than because it is dashed. So actually that wraps this up. We talked about 2 word problems. We talked about writing inequalities from a graph that's already given to you. So hopefully with more practice you feel confident. And again, feel free to ask me any kinds of questions that you have in class.